Hello, hello, I am Ugo, and this is the atoi leak code problem. So, I didn't know this was a thing in Python. Maybe that's not a good thing to. I, I, I think I saw the video. It said atoi in Python. I guess this is a function that converts a string into an integer. It's pretty cool. Um, I don't know when I would use it, but yeah, I didn't know it was a Python function until one of the videos showed it in the hint or whatever. I was just writing it based on what it was telling me to do. So there's a lot of words here, but basically all we're trying to do is we're gonna take a string, any type of string. It doesn't matter what type of string. We're just taking a string, and what we're doing is we are going to turn it into an integer if it is an invalid, well, not invalid, but uh okay, so first we had to ignore white space. So any white space at the start, we ignore it. Then if or no then we're gonna check for signs, because sometimes they'll put signs in it. So if they put like a little negative here, then that means it's going to be negative. Sometimes they'll explicitly say that it's going to be positive, so we have to handle that case, I guess, to like make sure that we're on the right index. So we have to worry about that, but that only happens once, and that's at the start. So after the white space and after that first character, that might be a sign, if there is a sign there at all. We are meant to just convert all the digits or numbers inside of the string into an integer until we reach a non-valid character, which would be a non-numerical character, or it's just not a digit. So we're just gonna iterate through it until we find a character that isn't a number. Um, so like in this case, as you can see, we start off with 4193, we continue, and then we get to a space, and that's where we stop, and that's the number that we have right here. But if we start off with words, well, that causes an issue because words, it's not valid. The only starting character that isn't a number that can be valid is a sign, so a negative or a positive sign. If it's not one of those, then we just immediately break out, and the output would be 0 in this case. Um, and then there's one extra case on top of that, which is in the notes section right here. Uh, well, I mean, it says that the only white space character that we have is space, so it's not, that seems normal. But the other case that we have to worry about is int max and int min. So in Python, at least, the number will expand and we'll be able to cover more. But if we ever get to a number that's bigger than what int max or int min would be in a 32-bit signed integer, then we're gonna want to just round it and return that number. So originally what I was gonna do is I was just gonna find the number and then after that do a check, but I realized that it would probably be more efficient to break out early if you ever find it, because I mean, after finding it once, you're just going to keep increasing. So this would keep it from growing very large unnecessarily. But yeah, that's the input, or that no not that, that's the input and the basically what we're supposed to do with this problem. uh yeah. And as you can see here, we have a very large number, and that number is actually bigger than the int min, or smaller than the int min. So because of that, we're going to round it back to the int min, and we're just going to return int min, which would be this number. So yeah. uh let's see, we have some constraints. The length of the string is less than 200 characters, and string contains these the English letters plus these things. So it's not gonna have some weird dashes, no dashes, I don't know, like weird symbols, I guess, or emojis or something. It's just gonna be digits, numbers, and a few signs plus a period and a space. Um, my original approach is very close to my final approach. There was one little difference I changed. But my original approach, basically, what we do is we first remove the white space. I originally thought, okay, I'm gonna store it in a separate string because I want to keep it as a pure function. Uh, but this, I'm pretty sure, yeah, no, I know for a fact that this isn't right because it would still be a pure function if I put a string here. Since strings are immutable objects, they're passed over not by reference. So, or well, at least you can't modify the string that gets put as an input. So if the user had an input variable of a string and they passed it in, your changes to the string inside of the function aren't going to affect the one over here. So I tested that out actually in Python Tutor. So I have it right here. I have s is equal to this, like with the white space. So I did that. If it did modify it, then printing it afterwards would have removed the white space because I used lstrip on it. But it didn't because it passes a copy over since it's an immutable object. And lstrip, or well, I'm not sure if it's because it's an immutable object or if it's because lstrip creates a copy since you can't mutate it. So then you're assigning a new value to it. Or a copy of it rather than changing. No, I'm pretty sure it's a little bit of both. I think lstrip creates a different string because you can't change strings in Python, and this, what's it called? You don't pass. It's not passed by reference. So I think it's a little bit of both, but yeah, that's the only difference really. Then we check if the string is empty now, because if it was just white space, then we have to return 0. This just ensures that we don't mess up by doing these checks down here. After that, we just check if it's we do a check to see if it's negative. So if there's a sign, then we gotta check for that. And this is where we start the index. I thought it would make more sense to do a while loop with an I as initialized beforehand, just because it's we're traversing the list, or we're traversing the string at different points and doing different things with it. So like keeping the index, like being able to move the index before even at the looping part would be nice. I think I could. I'm not sure if it would be. I don't think it would be faster to implement the manual strip, because all that would be we start the I at 0 up here, and then we go as long as I is less than the length of the string, and s of I is a space, and we just remove it or turn it into just remove it somehow, and we just no, we wouldn't even remove it. We could just skip over it. Yeah. But I feel like that would probably be more time consuming because I'm assuming that this function in Python is more efficiently implemented. So, or possibly even lower level like in C. So I'm not gonna change that, but I could do that, and then the I would make even more sense. But in this case, I'm putting it as 0 because we're gonna increment it if there is a sign, so then we can move past it without really having to deal with removing it like from the actual string, because strings are immutable, so that would be kind of time consuming, space consuming or something. So this would just make it easier to move forward without issues. And then let's see. Yeah, so if it's a negative sign, then we want to signal that it is going to be negative at the end. And if it just says positive, then that means it's explicitly stating it, but that doesn't mean anything. I'm pretty sure it says something up here. I don't remember where it says it. It says like assume. It says something like assume it'll be positive. I'm not sure if that's just an only code though. Basically, if there is no sign stated, then by default it'll be positive. The positive sign here is just a little thing to throw us off, I guess. Then we start off with answer is equal to 0. This will work later on for the turning the string into a integer because we're handling each character individually. And then I created an integer of int max, so this represents the maximum number that can be stored in an integer. And I didn't want to make an int min because int min is just int max minus 1 as a negative. Int max as a negative minus 1. So I was like, okay, if the answer ever gets above int max, then at a minimum the answer is going to be 2,147,483,648 because it has to be at least one bigger, and if it's one bigger then it is going to be equal to int min. So it doesn't matter if I return int min or not. I don't have to make a check for that because anything bigger than int max will either at least be int min even if it is negative. So yeah, that's the int max part. It also saves me time, so I don't have to do 2 to the power of 31, was it? Or 32? I think it was 31, right? Yeah, 31. So it saves me time on doing that, because if we had to repeat that operation all the time, then that'd be a bit of a pain and time consuming. I guess what I could have done is just 2 here, 2 to the power 31 here. It would be probably more explicit that that's what it is, but I just wrote it like this because that's the number. It helps me visualize that I can do this effect, like if that I can actually do that. That's the if I did 2 to the power 31, I wouldn't have seen that. But yeah, and then right here, this is the big thing basically. So since I started programming in C++, I don't think we have. I mean, we might have. Wait, hold up. Does C++ have it? Does C++ have atoi? Whoa, I did not know that. That's so cool. Anyways, at least my professor didn't teach us it. My professor made us do it manually. So what this one does is it essentially, basically, let's say we had negative 41, right? What happens is ans is going to be equal to 0 at the start, and we're going to get the first number or the first character, right? After checking, so first we get the negative up here we get the negative, and then we move forward one, so we don't have to worry about that. So we're going to be at index 1 already. Answer is going to be equal to 0. So what happens is we'll have ans time, or 0 times 10 plus the integer at the character that we're currently on. Since we're currently on 4, it would be 4, and that would give us 4. So ans is equal to 4. And then once we do that and we go to the next iteration, what's going to happen is we're going to have 4 times 10 plus 4. So basically what's happening here is it's moving the ones place over. It's moving everything 1 over to the left. I didn't know the exact term to call it, but it's basically just moving everything away from the ones place, because you're going to add to the ones place. And then we're moving it over 1 by multiplying by 10, since we're doing base 10, right? So oh wait, not plus 4. It would be plus 1 because of the 4, because now we're at 1. So the character we're currently on is 1, and we just add 1 to that, and whoa, we got 41, and that's the answer that we're looking for. So that's how this little part works. It's pretty cool. I liked learning it when I first learned it. But yeah, after doing that, each iteration, what we're going to do is we're going to check int max. If int max is less than the number, or if answer is greater than int max, so that means that we went over the maximum number that can be stored in a 32-bit. And then we just check if it's supposed to be negative or not. If it is supposed to be negative, we return int min. Otherwise, we return int max, because we're supposed to be rounding up or down, or we're supposed to be rounding to the maximums in case we go over or under them. So that's what this little ternary operator is doing. It's just returning int min if it is negative, and if it isn't, then we're returning int max. And then we just move forward 1 if that condition isn't true. And yeah, we do that until we either get to the end of the string or until we find a character that is not a digit. So once we're done with the while loop, if we don't go over the limits that we have in place, then we're just going to return negative of the answer if it is supposed to be negative. Otherwise, we return the answer itself. Yeah, and then if we look at the leak code things, pretty much the same thing. Just change this from being a different string to the same string, and everything else is just the same right here. But yeah, that's the solution for atoi. It's pretty cool. I like this problem. Uh, yeah. And then right here you see that that they print differently because strings are not changed when passed into functions, even if you mutate them within the function. So yeah, pretty cool. It's an O of n solution because we're only going to be going through the entire. This is an O of n operation basically, outstrip, because you can go through the entire list. We're going until we find something that isn't white space. And then after that, we're going until the end of the string. But there are some options for early exits, such as the current character not being a digit, the current character being over the maximum possible stored in a 32-bit integer, or the answer being under the below the minimum that can be stored in a 32-bit signed integer. So it's O of n, but there's some early exits. Overall, though, I'm pretty sure it basically ends off just being n, because this one stops as soon as it reaches a non-white space character, and then this one will start from that position until the end, or until there is a digit, a non-numerical character, and it has some breakpoints. So it's probably better than O of n, but it's close to basically just being O of n. And it's not, I don't think it takes up space. I don't think this would, because we're just, or at least in the final solution, we're just using the string that we currently are given. So yeah, that's it.